All right, welcome to The Explainer. Now, what if I told you that the key to diagnosing some of the most devastating brain diseases wasn't hidden in some complex scan or a painful test, but was actually hiding in plain sight? I'm talking about the simple glance of an eye. Today, we're going to dive into some absolutely fascinating research that suggests this might be the real deal.
I know, it sounds a little like science fiction, right? But a truly groundbreaking study is showing that our eye movements can tell this incredibly detailed story about what's going on inside our brains. And these stories hold clues to one of the biggest challenges in modern medicine. So, before we get to the cool eye tracking stuff, let's first get a handle on the problem they're trying to solve.
Okay, so here's the first major hurdle: dementia. It's not just one thing, it's actually a catch-all term for a bunch of different syndromes. And the really frustrating part, on the outside, they can all look frustratingly similar. This makes it a real nightmare for doctors trying to figure out what's what.
And this really gets to the core of the puzzle. You could have one person with Alzheimer's and another person with something called frontotemporal dementia, or FTD, and they could be showing almost the exact same symptoms. But if you could look under the hood, down at the molecular level, you'd see they are completely different diseases. And, telling them apart isn't just academic. It is absolutely critical.
So, what's causing all this damage? Well, it all comes down to different kinds of misbehaving proteins, kind of like tiny little saboteurs gumming up the works in the brain. FTD, for instance, is often caused by clumps of a protein called tau, or sometimes another one called TDP-43. And here's the bottom line. If we're ever going to develop drugs that actually work, we absolutely have to know which one of these bad guys we're fighting against. Okay, so that's the big question, right? How in the world do you figure out what's happening deep inside a living person's brain without some risky, invasive procedure? Well, this is where it gets really clever. Researchers started looking in a place you would never, ever expect: the tiny, rapid, almost unconscious little flicks our eyes make all day long. They decided to focus on something called saccades. Now, that sounds fancy, but it's just the technical name for the super quick jumps your eyes make when you shift your focus, like when you look from one word to the next on this screen. Yep, you're doing it right now. It feels completely automatic, doesn't it? But behind the scenes, it's an incredibly complex process.
And here is the brilliant part. Those little eye jumps, they're controlled by these really specific, finely tuned networks in our brains. So the big idea, the core hypothesis, was pretty simple, really. If one of these diseases is damaging those brain networks, well, then that damage should show up as a tiny, subtle flaw in the eye movements, like a clue left at a crime scene.
So how they put this to the test? Well, the researchers brought in some high-precision infrared eye trackers to record these saccades. And they looked at patients who had autopsy-confirmed brain diseases, so they knew for sure what was going on, and then they compared those results to a group of healthy individuals. Okay, first things first, let's look at our baseline. This is what a normal, healthy saccade looks like. A target pops up, and boom, the eye moves almost instantly. We'll call that latency, basically reaction time. See how fast it moves? That's velocity or speed, and it lands right on the money. That's gain or accuracy. It's just a clean, quick, efficient little jump. All right, now take a look at the pattern from a patient with Alzheimer's. You see that long, flat line at the very beginning? That is latency. It's a noticeable, significant delay before the eye even starts to move. In this study, this became the telltale signature for Alzheimer's, a slow startup. And whoa, this shows something completely different. This is from a patient with PSP, which is a type of dementia caused by that tau protein we talked about. Look at the movement itself. It's incredibly slow. That's low velocity. And you can see it doesn't even make it to the target in one go. It has to take these little stutter steps to get there. It's slow, it's inaccurate, it's a completely different fingerprint. But this is where things got really interesting and honestly pretty unexpected. This pattern is from patients with that other major type of FTD, the one caused by the TDP-43 protein. And their eye movements, well, they looked pretty much normal. Fast, accurate, just like the healthy group. And this was a massive discovery. It meant that the absence of a problem was, in itself, a really important clue. So when you lay all these clues out on the table, a really clear picture starts to emerge. It turns out each of these diseases leaves its own unique, measurable fingerprint on our eye movements.
Let's just break it down real simple. For Alzheimer's, the giveaway is that long delay, that high latency. For the dementias caused by tau, it's the slow and inaccurate movements. And for the TDP-related dementias, the clue is that their eye movements are, well, normal. You've got three totally distinct patterns for three totally distinct diseases.
And wow, look at how dramatic this is when you actually visualize it. This chart is showing the speed, the velocity of vertical eye movements. You can see the healthy controls and the Alzheimer's patients are both pretty fast. But then, look at the PSP patients, the ones with the tau problem. Their eye movement speed just falls off a cliff. It is a massive, quantifiable difference.
You know, the researchers themselves really summed it up perfectly. This quote gets right to the heart of what they found. If you see slow and inaccurate saccades, it's a really strong sign that the damage in the brain is being caused by that tau protein.
Okay, so what does all this mean for the future? Why are we getting so excited about a simple eye test? Well, because this could be a genuine game changer. The potential impact here is just huge.
And get this, the research didn't just stop at observing the eye movements. It actually connected the dots. The studies showed that those slower vertical eye movements were directly linked to physical damage, actual atrophy, in the exact part of the brainstem that controls them. I mean, that's a direct line from the symptom you can see to the problem deep inside the brain.
But here's probably the most incredible number from the entire study. On average, these unique eye movement signatures, they were detectable more than 2.5 years before the patients passed away, and their diagnosis could be confirmed by an autopsy. Just think about that. That is an unbelievably early and accurate signal.
So let's just imagine the future for a second. A future where a simple, totally non-invasive eye test can tell a doctor not just that a patient has dementia, but precisely which rogue protein is causing it. This would let us enroll the right patients into the right clinical trials for drugs that are designed to target their specific disease. It could dramatically, and I mean dramatically, speed up the search for a cure.
It's a really profound thought, isn't it? That the answer to one of the most complex, heartbreaking puzzles in all of neuroscience might just be found by carefully watching something as simple as a glance. And if that's true, well, that could change absolutely everything.